Introducing the rocket stove. Tired of smoky fires that waste wood and fill your space with unhealthy air? Traditional stoves are inefficient and bad for your health. Enter the rocket stove. A simple, super-efficient heater that burns wood cleanly, producing almost no smoke. Rocket stoves use less fuel, save money, and are better for the environment. They're easy to build, require basic tools, and anyone can do it. In this guide, we'll show you step-by-step how to make your own rocket stove heater. Ready to breathe easy and stay warm? Let's get started. So, how exactly does a rocket stove work its magic? What are the key components that make it so efficient and powerful? Let's dive into the inner workings of this ingenious design and explore the science behind the flame. At its core, it's all about achieving a super hot, incredibly well-insulated burn. This intense heat is the secret to the rocket stove's efficiency, allowing it to extract the maximum amount of energy from the fuel. The fuel magazine is the starting point, the place where you load small sticks, twigs, or other readily available biomass. And the beauty of it is, no big, cumbersome logs are needed. This makes fuel gathering much easier and more sustainable. Gravity then takes over, gently feeding the wood down into the heart of the fire. This creates a steady, controlled burn, ensuring a consistent and reliable heat output. Next, we have the combustion chamber, often referred to as the burn tunnel. This is an L-shaped, heavily insulated tunnel where the wood undergoes intense combustion, burning at incredibly high temperatures. This high-temperature environment promotes complete combustion, effectively turning smoke into even more usable heat. It's a secondary burn that maximizes efficiency. And the key to maintaining these extreme temperatures? Insulation. It keeps the precious heat locked inside the combustion chamber. This insulation is crucial for making the burn not only cleaner but also significantly hotter and more efficient. Finally, we have the heat riser, which is essentially an insulated vertical chimney. This riser plays a vital role in pulling the hot combustion gases upwards at a rapid pace. This rapid ascent creates a strong draft, and it's this draft that produces that signature whooshing sound we associate with rocket stoves. This powerful draft is more than just a sound effect. It actively feeds more air into the fire, dramatically boosting the overall combustion efficiency. The culmination of all these features? More usable heat generated from less fuel. And as a welcome bonus, significantly less smoke released into the atmosphere. Ultimately, this all translates to maximum fuel savings, making rocket stoves an incredibly efficient and environmentally conscious heating solution. Let's talk tools and materials. You'll need a metal cutting tool, angle grinder or hacksaw, a welder, measuring tape, marker, clamps, and most importantly, safety gear, glasses, gloves, and a welding helmet. For materials, use steel pipes or square tubing. 4-inch for the fuel magazine and burn tunnel, 6-inch for the heat riser. Check scrap yards for affordable metal. Insulation is key. Perlite, vermiculite, or clean wood ash work well. You'll also need an outer shell, like a metal drum or can, to hold the insulation. Add a small metal grate for airflow and some sheet metal for a heat reflector. Gather your supplies and let's build. Safety first. Always wear your protective gear and work in a ventilated area. Cut your 18-inch fuel magazine and 12-inch burn tunnel from 4-inch steel tubing, each with a 45-degree angle at one end. Fit the angled ends together to form a precise L shape, the heart of your stove. Clamp the pieces tightly and check the fit. Weld the seam all around for a strong, airtight joint. Practice welding on scrap if you're new. Let the assembly cool before handling. You've just built the core of your rocket stove. Next, let's add the heat riser and insulation. Now let's move on to a crucial component of our rocket stove, the heat riser. This is where the magic truly begins, as it plays a vital role in maximizing heat output and ensuring efficient combustion. The heat riser is the heart of the rocket stove, responsible for creating a strong draft and channeling the intense heat upwards. We'll be using a 24-inch long 6-inch diameter pipe for this build. These dimensions are important for achieving optimal performance. A pipe of this size provides ample surface area for heat transfer and allows for sufficient airflow, contributing to a hotter and cleaner burn. Remember, precision in measurements is key to a successful rocket stove. This pipe will be positioned vertically on top of your burn tunnel. Ensuring it stands perfectly upright is crucial for maintaining proper airflow and preventing any obstructions that could hinder the stove's efficiency. A secure and stable vertical mount is essential for the overall functionality of the rocket stove. To connect the heat riser to the burn tunnel, you'll need to carefully cut a hole in the riser. This hole should precisely match the dimensions of the burn tunnel opening. Accuracy is paramount here, as a snug fit is necessary to prevent any air leaks that could compromise the stove's performance. Once the hole is cut, securely weld the heat riser to the burn tunnel, ensuring an airtight seal. This airtight connection is absolutely critical for maintaining optimal draft and preventing any dangerous fumes from escaping into your living space. A strong, leak-proof weld is a non-negotiable aspect of rocket stove construction. Now it's time to build an outer shell around the core of the rocket stove. This outer shell serves multiple purposes, including providing structural support, containing insulation, and enhancing the stove's overall aesthetic appeal. The outer shell is an integral part of the rocket stove's design, contributing to its durability and efficiency. When constructing the outer shell, be sure to leave a 2-3-inch gap between it and the heat riser. This gap will be filled with insulation, which plays a crucial role in retaining heat and maximizing the stove's efficiency. The insulation gap is a key element in preventing heat loss and ensuring that the stove operates at its full potential. For insulation, you can pack the gap with perlite. Perlite is a lightweight volcanic glass material that provides excellent insulation properties. It's also fire-resistant and non-toxic, making it a safe and effective choice for rocket stove insulation. Alternatively, you can use vermiculite. Vermiculite is another excellent insulation material, known for its ability to expand when heated, creating a tight seal that prevents heat loss. Like perlite, vermiculite is also fire-resistant and safe to use in high-temperature applications. Or for a more sustainable option, consider using wood ash. Wood ash is a readily available and cost-effective insulation material, particularly if you have a fireplace or wood-burning stove. It provides decent insulation and helps to reduce waste. It's essential to ensure there's an air opening at the bottom of the fuel magazine. This opening allows air to enter and fuel the combustion process. Without adequate airflow, the fire will struggle to burn efficiently, and you won't achieve the desired heat output. Install a metal grate or shelf within the fuel magazine to facilitate airflow. This grate elevates the fuel, allowing air to circulate freely underneath and around it. This ensures a more complete and efficient burn, maximizing heat production and minimizing smoke. The air flows under the grate, providing a constant supply of oxygen to the burning fuel. This undergrate airflow is a key principle of rocket stove design, promoting efficient combustion and reducing the amount of smoke produced. This consistent airflow feeds the fire, resulting in a hot, clean burn. A clean burn not only maximizes heat output but also minimizes harmful emissions, making your rocket stove a more environmentally friendly heating option. Direct the exhaust from the top of the heat riser into a suitable exhaust system. This is where the hot gases and any remaining smoke exit the stove. Proper exhaust management is crucial for safety and efficiency. Consider routing the exhaust through a drum or bench to capture extra heat. These thermal mass structures absorb and store the heat from the exhaust gases, gradually releasing it into your space over time. This significantly increases the overall efficiency of your rocket stove. Always vent the smoke safely outdoors using a chimney or exhaust pipe. This is essential for preventing the buildup of harmful gases inside your home. Remember, never use a rocket stove indoors without proper ventilation. Carbon monoxide poisoning is a serious risk, and adequate ventilation is crucial for ensuring your safety. To further enhance the stove's heating capabilities, add a heat reflector behind it. A heat reflector is typically made of metal and helps to redirect radiant heat back into the room. This simple addition can significantly improve heat distribution, ensuring that warmth is directed effectively into your space, making it feel cozy and comfortable. With all these components in place, your rocket stove is almost ready to fire up. Get ready to experience the efficient and sustainable warmth it provides. Alright, the moment we've been waiting for. It's time for the first test burn of our newly constructed rocket stove. We've put in the work, now let's see if it pays off. Safety first. Always do your first burn outdoors. This is crucial for a number of reasons. Make sure you're well away from anything flammable like buildings, dry brush, or overhanging trees. Give yourself plenty of space, and absolutely have water or a fire extinguisher nearby. It's better to be safe than sorry, especially when dealing with fire. A bucket of sand can also work in a pinch. To get things going, start a small fire with dry twigs. The drier the better, as this will help the fire catch quickly and easily. Carefully place these twigs in the fuel magazine, ensuring there's good airflow around them. Now, with a long match or lighter, light it at the burn tunnel entrance. Watch closely as the flame begins to take hold. Listen carefully for the rocket sound. It's a distinctive whooshing or roaring sound. That sound is a sign of strong draft and efficiency, indicating that the stove is drawing air and burning fuel effectively. Once the stove is hot, your stove should burn cleanly. This means that the combustion process is complete. Ideally, you'll see almost no visible smoke coming from the chimney. This is a key indicator of a well-designed and properly functioning rocket stove. One of the biggest advantages is that rocket stoves can use up to 70% less wood compared to other methods. This is a massive reduction compared to traditional open fires, which waste a significant amount of energy. This efficiency translates to saving time, as you spend less time gathering and chopping wood. It also saves you money, because you need to purchase less fuel. And perhaps most importantly, it benefits the environment by reducing deforestation and air pollution. Building one of these stoves is surprisingly affordable, making it accessible to a wide range of people. It's even more cost-effective, especially when you utilize recycled materials that you might already have on hand. So go ahead and enjoy your efficient, clean-burning heater. Feel the warmth and satisfaction of sustainable living. And don't forget to share your success, your knowledge, and your experience with others who might be interested. Welcome to the Rocket Stove Revolution. Together, we can make a difference.